let's study third equation of motion. Here it is v square equals to u square plus 2as, where v is final velocity, this u is initial velocity, this acceleration, this a is acceleration, this s is displacement. Okay, this acceleration has a condition. Acceleration must be fixed constant uniform acceleration. Okay, this must be constant. Acceleration has a condition here that it must be constant, otherwise this will not be valid. Okay, acceleration must be constant. We should remember this condition. This equation is valid for constant acceleration, uniform acceleration you can say. And this relation is also called, what will be called, which type of relationship? This is what? Velocity. This is displacement or position. Okay, displacement or position you can say. This is also called velocity position relation. Okay, or you can say position velocity relation. You can also say writing position first, position velocity relation. This is also called position velocity relation. Okay, now there are two types of derivations of third equation of motion. First one is by graphical method, second one is by calculus method. Now let us see at first graphically, by graphical method. It's derivation by graphical method. Let's plot the graph. This is velocity upside, this is time this way, this is u initial velocity, this is final velocity v, this is time, let it be point t, let it be point p, and let's join this is point q, let it be r, this is o. Okay, this is the diagram where this distance will be v minus u, where this is v, this is point u, so this distance will be v minus u. So in this are equal, so this is also equal to v minus u. This distance is v minus u. Okay, now let us solve this. We know that this is a trapezium. Why this is a trapezium? This is a trapezium because the two sides, these two sides, this QT and OP are parallel to each other. Okay, now we will find the area of this trapezium, the shaded part. What will this provide? Area of this velocity time graph will provide displacement. Okay, so we will write here is equals to area of trapezium. What is a trapezium here? P Q, you can say start from O P Q T. Okay, area of trapezium this, and we know area of trapezium by mensuration. What is this? This is half into sum of parallel sides into height. Okay, half into sum of parallel sides is what? OP plus QT. This and this are parallel. This QT and this OP are parallel sides. So sum of parallel sides into height is what? This is height. Distance between them, okay, is the height. So OT here. S equals to this. Implies S can also be written as half into this OP is what? U. This QT is what? V minus U. This QT is not V minus U. This QT is equal to this, and this is what? V. This complete is final velocity. This is this into T. Now what is seen here? Now S equals to half U plus V into what we will write in the place of T. What we can write? What is this? In fact, we see this is position velocity relationship. Means position velocity means there is no time here. Okay, we have to release this T. Okay, we have to terminate this term T. We will put some value in the place of T so that T is omitted from here, because the relation is already mentioned here, position velocity relation. In this equation there is no term of T, so we have to omit this, terminate. To omit this, what we will do? From first equation of motion, we will remember the first equation of motion. What is that? V equals to U plus AT. From here, T can be equal to V minus U by A. Okay, so put this, we put V minus U by A in the place of T. Okay, then on solving, after all, now it is a calculation only. After calculating, we will simply get A square equals to U square plus 2S. We will get it. Okay, proved. Okay, this is simply calculation. Thereafter, we have to use first equation of motion. Okay, to get the value of T and nothing else. Simply the steps are, we find the area of trapezium, that is equals to S. Distance traveled is area under velocity time graph, we know that. So S equals to area of trapezium, this shaded part up to which final velocity is there. Now this is a simple calculation. We put the value of T as this by using first equation of motion, and after simply calculating we will simply get this. Okay, why we terminated T term? Because this is position velocity relation. Okay, this is, there is no term of time here, so we have to omit this. Okay, now let's see the calculus method. Now let's see the derivation by calculus here. We must remember this, that this is a position velocity relationship. This equation is a position velocity relationship. Here we need to drop the terms of T. Okay, that is time. So here again we see acceleration A equals to what? dv by dt. Okay, A equals to dv by dt. Here we have to drop the term dt because it contains t. Okay, this because this is a position velocity relation, we have to drop the terms of t only, and we will simply get the derivation. Okay, so what we will do to drop it? We can also write this as dv by dx into dx by dt, multiplying dx by dx to both numerator and denominator. Okay, so dx by dt will be what? Velocity. This is a velocity term, so it can be written as v dv by dx. Acceleration it can also be written as v dv by dx. Okay, so cross multiplying this we will get dx equals to v dv. Okay, it can be get. Now integrate both sides. Now integrating, what we will get after integrating? A dx integrating v dv. X, for x, the here it is, where it is x naught, initial position, it is final, and for velocity it is initial velocity u and final velocity v. Okay, now this is a dx. So calculating, a will be outside this because a is a constant. We have already considered this is a prime consideration, that acceleration is constant in third equation. In any first, second or third, in all the three equations acceleration is considered as a constant. So it is, this is x naught, this is x, this is dx equals to what? This will be, we simply solve it, v square minus u square by 2 it will come. This is now calculation. Okay, and this will come to what? A into x minus x naught. This will be equal to v square minus u square by 2. Then upon solution we will get what? We will get simply v square equals to u square plus 2a x minus x naught. Okay, x is what? X is displacement term. Okay, x minus x naught is what? This is displacement. So v square equals to u square plus 2a s. We can put in this place, we can put s. S is displacement. X minus x naught is what? Displacement. This final position, this is initial position. Final position minus initial position is what? Displacement. So it came here, and what we got is the required result proved. This is by integration method. So what we did here, we simply written the formula. We already know acceleration equals to dv by dt, and we have to drop this term. For dropping this term, we multiplied dx on both numerator and denominator. Okay, and then dx by dt is put as v. Okay, and then the game starts. Okay, now there is no term of t here, so it is solved easily. Okay, now let's say one example. Here is a question. A car starts from rest and moves 2 kilometers at 10 meters per second square. What is this 10 meters per second square? This is acceleration. Find final velocity. Okay, what is given here? Initial velocity, because it is rest, so initial velocity is 0, and s is 2 kilometers means 2000 meters, and acceleration is 10. This is given. We have to find what? Sorry, v equals to what? So we know the formula, v square equals to u square plus 2as. Okay, putting all these values we will get v square equals to u is 0, so this does not mean anything. 2 into acceleration is 10, s is 2000, and that will be equal to 2 to the 4, 1 0 2 0 3 0 4 0. Okay, so v is under root 4, 1 2 3 4 zeros, and what will be the value? So the value will be what? 200 meter per second. This is the answer. Okay, we got the final velocity by using third equation of motion. Thank you.